Welcome! In this presentation, we will introduce you to an application created by my colleague Andreas Weber and myself, Rainer Kergel, as part of a university project. It is about the detection and recognition of buttons for the visually impaired. In many day-to-day situations, it is necessary to choose among a set of buttons, for example when using a remote control or when picking the desired floor in an elevator. Blind or visually impaired persons might not be able to identify the symbol on the button though. The application is to be used as follows. The user must hold the remote control vertically and place a finger directly below the button he wishes to know the symbol of. This must be captured by a camera or webcam that directly faces the remote control in a distance of about 15 centimeters. The symbol is then acoustically played back to the user. We first try to detect all buttons of the remote. Afterwards, we locate the fingertip position and choose the button above it. Finally, we classify that button's symbol. We are now going to explain the first two steps. Our segmentation algorithm is based on ED lines, a very fast line segment detector. This is how an output of that detector might look like. Each red line is a line segment. As you can see, the segments are ordered in such a way that those belonging to the same button have subsequent indices. Starting with segment 1, all segments up to number 6 are added to the first button, colored blue here. Segment 7 though is too far away from number 6. The blue button is considered finished and segment 7 starts a new button, colored yellow. The same applies when moving from 10 to 36. We successfully detected the buttons. To find the fingertip now, we use a very simple unsupervised skin segmentation algorithm based on color. We consider parts of the image that are rather red to be skin. On the right side, you can see the resulting skin mask for the image on the left. As is the case here, usually not all skin pixels are immediately detected. We therefore adaptively change the contrast in a way that maximizes the amount of skin pixels. We then use region growing on the binary skin image to find the biggest detected skin region, which is assumed to be the finger. For the vertical coordinate of the fingertip, we simply use that of the topmost point of the finger. To get the x-coordinate, we consider the topmost 30 horizontal lines of pixels of the finger. We then compute the mean of the x-coordinates of these pixels. Despite the presence of background objects, the fingertip and the corresponding button can be detected robustly. We evaluated our method using two remote controls at daylight and achieved accuracies of about 72% and 61%, which is much better than chance. In some situations, the method cannot work correctly. Remote controls with low contrast between the buttons and the remote's general color can prevent the detection of buttons. Skin patches or bigger red objects above the actual fingertip lead to a wrong fingertip position. If the remote control is rotated too much, the wrong button is used for classification. If the camera is too far away, the button classification fails. If it is too close, no buttons are detected at all. Thankfully, at least the last three situations can be avoided by teaching the user how to use the application. We will now show you videos of using our application with two remotes.
Menu. Source. Mute. Enter. 7. 4. 1. TV. 1. 2. 5. 6. 3. Eject. On off. 8.
As you can see, our method can also work with other kinds of buttons, like these in an elevator. Thank you for your attention.